I'm going to give the first lecture. So this is almost the plan of what we think might happen. And hopefully most of it will happen. I'm going to start talking about the UN Sustainable Development Goals, food security, prospects for GM crops, and a bit of history to the field to sort of get things in context for you. Then Stuart Cassen's going to do some of the more difficult bits about the technologies of how we actually produce new plants through biotechnology. We do have some coursework on this module, so you will be doing a group presentation, and it's quite fun. So we'll be telling you about what that is in Lecture 6. Then Stuart will tell you a bit more about some of the different successful biotech crops that are being grown and are on the market. Then I'm going to tell you a bit more about engineering food quality and trying to make drugs in plants. Then we're very lucky that Casper Chater is going to give you a lecture on the use of Arabidopsis thaliana as a model system where most of our gene discovery work happens. Stuart's going to do a couple of lectures about nitrogen, which is something that really limits plant growth and is a grand challenge for the future. Matt Johnson is going to do a couple of lectures on how we may improve photosynthesis in the future and what's going on in the labs and could work its way through. We're giving you a couple of free lectures to be getting together in your groups and preparing these presentations, and then the date you need to remember is that you're actually going to be doing the group presentations, which do count towards the module mark, on the 24th of March in the afternoon up here. Okay, all happy? Yep. Okay. So, I don't know if any of you went to when there was climate protests down on the concourse last year, and our VC turned up and said that every module was going to include sustainability from now onwards. You Vice Chancellor. So I thought I'd tell you up front, where are we fit into sustainability and the UN Sustainable Development Goals. So this followed on from the Millennium Development Goals. So the United Nations have set goals for us all to be aiming for, and you can look these up on the website. And where I think that we fit in is Sustainable Development Goal 2, which is zero hunger. So you can click on these and see about them. So the food and agriculture sector offers key solutions for development is central for hunger and poverty eradication. So I guess that our module is trying to explain some of the ways that biotechnology could be used to try and address Sustainable Development Goal 2. So you can look at all of those, and I recommend you to look at them. So where did I get to? So, zero hunger. Why do we have a Sustainable Development Goal for zero hunger? Well, many people in the world don't have enough food. I mean, the UN estimates about 800 million people don't have enough food, and that thousands die every day from malnutrition. Many of these will be children, probably in sub-Saharan Africa. So hunger is not distributed equally throughout the world. There are some regions of the world where these UN Sustainable Development Goals are far more important. So we have to bear that in mind when we're thinking about making new crops. Who are we making them for? Why are we making them, and how are we going to address these goals? Okay, so just to give you an idea of the number of people on Earth, this timeline I think is quite interesting. So if you go back 200 years before most of you were born, from 1800 to 1900, the population grew by about 60%. Then over the last 100 years, from 1900 to 2000, it went up by about fourfold. So huge increase in the 100 years before you were born. And much of that can be put down to technological innovations. So does anybody know who these two people are, whose pictures I've put up here? They both have Nobel Prizes.
The one on the right is Norman Borlaug.
That's right, yeah. Who's said to be the father of the Green Revolution, and you'll be hearing quite a bit about him. The other one is Fritz Haber, who is co-discoverer of the Haber-Bosch process to do with fixing nitrogen, being able to take nitrogen from the air and use it as fertilizer. So between them, they're probably responsible for being able to sustain the life of a third of the people on Earth. So without those two technological advancements, Earth would support about 4 billion, our agriculture, and now it's supporting over 6 billion of us. So what Norman Borlaug did, and Stuart's going to tell you a lot more about this tomorrow, is he used plant breeding to produce better crops. And one of the things he did was make a lot of our cereal crops shorter so that there was less energy going into the stem and more going into the grain, so higher yields. Another thing he did was change flowering time so that you could get more crop cycles per year. And he did that extremely effectively so that India changed from a net importer of food to being a net exporter of food, so really increased food yields around the world. However, Africa mostly missed out, actually, that African crops weren't included in his programs initially, and then funding became more difficult, and right into his 90s he was still trying to breed crops for Africa. So what's going to happen in the future? I mean, which is where you come in. So by 2050 we are expecting there to be 9.4 billion people on Earth. That's half as many as almost there are now. So we're still predicting a huge increase, and we're going to have to feed all those people on the same amount of land, because we need to maintain diversity. We don't want to give any more land over to agriculture, and in the face of climate change. So in the face of there being erratic rainfall, perhaps periods of flooding, periods of drought, pathogens moving because temperatures are changing, temperatures affecting plant fertility. So huge challenge actually in being able to feed enough people. So just to look at some of those population predictions from the UN, this is one of those graphs that spreads out at the end with the highest and lowest predictions in the fanned out area. So you can see at the top in purple, world population is going to grow. This is the log scale, but it's not going to be the same everywhere. So if you look at that blue line in the middle, Europe, actually, we're not growing. So the problem is not so acute for us. But then the steepest one is Africa, where the population explosion is going to be much higher. So just in the place where I said most people are liable to malnutrition, we are expecting the biggest growth in people. So this is going to impact differently around the world. So if these predictions hold true, we're looking at about 200,000 extra people a day to feed. So we have a huge food security problem facing us. And it's been described as a perfect storm, that we've got this growing population at the same time as climate change changing our agriculture. How are we going to cope with it? So Norman Borlaug, just to go back to him, he said that, so he gave a speech when he accepted his Nobel Prize, as all Nobel Prize winners do, apart from Bob Dylan, I think. And he said the Green Revolution has won a temporary success in man's war against hunger and deprivation. It's given man a breathing space. If fully implemented, the revolution can provide sufficient food for sustenance during the next 3 decades. He said that in 1970. And he was absolutely right. We are now facing a food security crisis. So he has sustained the life of many people on Earth, but we now need new technological advancements. And what they're going to be, I don't know. One of them could be genetically engineering crops and food, but it's not going to be the only answer. There are actually all sorts of political problems, food distribution, food waste problems that we need to address as well. So I don't want you to go away from this course thinking that plant biotechnology is going to solve all the problems, because it's not. There are a lot of other problems that we have to address to solve food security. Okay, so GM crops could be part of the answer, but also they're not accepted in many parts of the world. So this is the front cover of Time magazine, and this is a Swiss scientist, Ingo Petrakis, and I'll tell you about his work later in the course. And this says, this rice could save 1 million kids a year, and that was July 2000, and we will talk about his work later. Still nobody has eaten it because of lack of acceptance of GM foods, and we'll be looking at why that might be. So some of the technologies are there, but getting them accepted as well is going to be a real problem, or is a huge challenge. Okay, so GM crops, the ones we've made so far, can do quite a lot of things in reducing losses or improving nutrition and things, but they're not always through increasing yields, more through reducing things. So I wanted to look a little bit about how successful GM crops have been and why it's different in different parts of the world, and just how much has been eaten. So, as I'm sure you know, Europe is fairly anti-GM, whereas in the States they've been eating quite a few modified crops, growing and eating them since the 1990s, so over 20 years. So this is more than 3 trillion meals. This is a big experiment to show food safety, because at the moment there hasn't been a single substantiated case of harm. And yet still people are protesting against it. Still it's not culturally acceptable. Even in the States there are protesters. So this is saying, Wake Up USA, your dinner is banned in 30 countries. And sick of lies, what are we saying? Sick of lies, sick of greed, we don't need your toxic seeds. So clearly there is opposition, and this isn't an easy fix by any means. So I want to spend a minute looking at some of the successes of GM crops throughout the world, and then we'll look at some of the problems. And I want to look at the data that is collected by an organisation called the International Society for the Acquisition of Agri-Biotech Adoption or something. Very snappy title. So this is a film that, if I can show it to you, that they made to celebrate 20 years of GM crops in so this is going back to the 2016 figures. So the figures are always a little bit behind by the time they've collected them and released them on agriculture. But this is saying that 18 million farmers. So just watch this film, and then we'll go through some of the numbers on slides if we can watch it. So it's only a few minutes, but it gives you an idea of how much has actually been grown. Because I think in the UK we sort of think it's not happening. Okay, so I recommend you look at their website because I mean it is quite good. We'll go back to. Okay, I've lost where we were, but we'll get there. No, don't do that. Okay, so this is a year later. This is the most up-to-date report on the website. So they do a sort of state of adoption of biotech crops report every year. So this is just so you've got some of these numbers. So the big crops are soybean, which has been engineered to be herbicide tolerant, so it can be so it can tolerate glyphosate, so we can get rid of the weeds, and that helps farmers not have to spray so much weed killer, not have to get a tractor out. The next big crop is maize, which again is herbicide tolerant. Next one is cotton, which is tolerant to particular insect pests, so again not spraying insecticide. And then there's a smaller amount of rapeseed or canola, which is again herbicide tolerant. So not a huge diversity of crops. The others is a tiny slice. There's not many that are out there and being grown on a large scale. You can see that biggest adopter is on this bar chart is the US, then Brazil, Argentina, Canada, and then after that India. So a lot of growth in the Americas. Oh, I've just put a note at the bottom about what a hectare actually is. So it's saying, because it's not an SI unit really, that 17 million farmers were growing biotech crops in 2017 on about 90 million hectares. And a hectare is a 100 metre by 100 metre square, so there's 100 hectares in 1 square kilometre to make that make some sense. So I guess that means almost 1 million kilometres, square kilometres. So this is an area that's probably twice the size of the UK agricultural area. So we might think we're not doing it, but there are whole bits around the world that are doing it. And the adoption rate of these crops is really high. So virtually in the countries that grow these crops, virtually all the soybean, over 90% of the soybean and maize and cotton are now GM. So where they're accepted, they have been overwhelmingly accepted. So this idea they were talking about conserving biodiversity, well, what they mean is if you're getting more yield off a crop, then you don't have to dig up any more land to grow more crops. So it's land-saving technology. It prevents deforestation. And they are estimating that over those 20 years from 96 to 2016, the productivity gains, and this is usually from preventing losses, are 183 million hectares, which means that that's been saved from deforestation. They're also saying that it makes, there are environmental benefits, because if your crops have built-in weed killer tolerance, they have built-in insect tolerance, you don't have to get your tractor out, you don't have to spray so much, and therefore you are saving energy and saving on CO2 emissions. So they're saying it's saving millions of kilograms of pesticide from being sprayed, which means that you don't have to build a factory to make that pesticide and all the CO2 emissions associated with that. You don't have to get your tractor out to spray it. And that's in total is, in just 1 year, is saving 48 million kilograms of pesticide. And if you add that up into CO2 equivalents, they're saying that would be equivalent to taking 16.7 million cars off the road for a year. So we're talking about big areas and big numbers. Now, the ISAA are pretty GM positive, but again, they're using accurate figures. So there's some interesting stuff to look at on their website. They're also saying that that it contributes to food security, that crop prices are lower because it doesn't cost the farmers as much to make them. So increased yields, increased income gains. And I think I put on the website a paper by some economists where they've taken these figures from, actually. So these are figures from real economists about the income gains to farmers. And the income gains are going more to the farmer than are going to the company that makes the seed. Okay. But in the UK we have quite a different picture and quite a different idea about GM crops. If you go home and talk to your family about them, you might get quite a different response. They wouldn't be saying it took 197 million cars off the road, CO2 wise. You know, they wouldn't be saying nice things about them. And our press is really very anti-GM. So these are admittedly some quite old cuttings, but things come up in the press quite regularly. Quite emotive stories about how GM could be really bad for our health, and yet there is no evidence that it could be bad for our health. So this one in the Daily Mail in 2011, GM in your cornflakes, food fears. Well, actually that story is about making maize that has an extra amylase enzyme in so that it will be good for bioethanol production. It's never intended for food use. That woman is not going to be poisoned by it. And even if she ate it, no, she wouldn't be poisoned by it. It'll be in a different stream to the food. Then this is quite a big one that comes up quite often, this particular story that came from a French scientist, Seralini, and he's often cited, where he's done studies where he has fed herbicide-tolerant crops to rats, and these are rats that that have been engineered to have a much higher rate of tumorigenesis. So these are rats that have been bred for increased tumour development, and they're often used to test things. And what he said that was, when you fed them the genetically modified diet rather than the comparative one on the right, on the controlled, or the genetically modified with the herbicide, the Roundup, then they got more tumours. But so that was the original paper that was published, and as you can see, they all get a lot of tumours. But when they reanalysed the data, it was the paper was retracted by the journal because the sample size was too small to do enough statistics to say that this was true. And yet, these things still make the headlines because they're out there. So once the story is out there, it sells papers. People like to buy a paper with a shock horror story in it. They don't want to buy a paper that says your food is safer than it has ever been in history. That doesn't sell newspapers. So these stories do persist, and you know, these are genuine scientists doing this work. Thing is that they sort of get taken out of context and blown up, and the fact that it was retracted later just doesn't make the headlines. So, you know, this got right up to the French Prime Minister, who said that if it was confirmed, they'd press for a Europe-wide ban on importing this maize, and the Russians suspended importing GM maize because of this story, and all sorts of things. And then Kenya banned all GM crops because of it. And that is quite a dangerous thing. So our attitude to GM crops does affect the world. So we have plenty of food in the UK. We can afford to be choosy about what we eat, and if we think there's a risk, we will abide by the precautionary principle, and we won't take that risk, which is entirely understandable and human nature. However, when there are famines in the world, so there was a big famine in the Horn of Africa in early 2000s, and many people were dying, and other countries were donating food, many African countries, Zambia for example, rejected that food. They wouldn't allow it in for months. So the US food aid that was sent was not allowed in. People were not allowed to eat it. And this wasn't, well, one reason they thought it wasn't safe, but the more important reason is that they were scared that their farmers would plant these seed, it would get into their agricultural system and contaminate it with GM, and then they wouldn't be able to export to Europe, so it would ruin their exports. In the end, they got round it by milling the seed and just sending in the milled grain. But it does show that our attitude to GM food doesn't just affect us, it affects global markets, it affects people around the world on how much food they have to eat. And I think I've put this paper on the website for if you want to read it. Okay, so why did the UK become anti-GM? Why on earth do we have these headlines and react against it so much? And you know, why whenever anyone tries to grow GM crops here, and some are licensed to be grown here but just aren't grown, or when scientists do trials, the Greenpeace come along and dig them up? Well, you've got to go back to the 1990s when GM food was first coming on to the shelves. What was happening at the same time at the end of the 1990s that really turned the British public against food technology in general? So the big thing that was happening was a really big food and important food scare around mad cow disease, bovine spongiform encephalopathy, which is a prion disease, and it was caused by feeding animals food of animal origin, so perpetuating the disease and the contamination chain. So that's no longer allowed. So this disease was extremely frightening. It's a degenerative disease. It attacks the central nervous system and the brain. And see, it just causes these lesions in the brain. People gradually get iller and eventually die. It has a really long incubation period. We didn't actually know how long the incubation period would be when this started appearing. It it could be about 20 years. And the thing that caused the mistrust was the government said that our beef was safe. So this is the Minister for Agriculture, John Gummer, making statements that our beef is safe and going to the agricultural show and feeding his daughter Cordelia a beef burger and publicly putting that on the front pages saying look how safe our beef is, and yet it wasn't. So by 8 years later 32 people had died. So it has a long incubation period. We didn't know how many people were going to die. So by the end of the 1990s, if he was saying it's safe in 1990, by 1998 there were a lot of high-profile deaths, and we didn't know, people had been eating it for a decade, people didn't know how many there were to come. So there was an eradication program of cattle, so 4 million cattle were killed. The EU would not accept our beef for 10 years until 2006. We couldn't export beef, so this was a huge thing, but it was a huge food safety concern. And it meant that people just didn't trust politicians or scientists about what they were saying about the safety of food. So that was one of the things that was happening at the end of the 1990s, just as GM food was being introduced onto the shelves. Another one was a television programme, A World in Action, that went out on ITV in '98 as well, and a scientist from the Rowlett Institute said that he'd been doing experiments where he genetically engineered a snowdrop lectin into potatoes, which, isn't a terrible thing to do. Lectins are anti-feedants for insects, so it would be a good insecticide. Snowdrops are pretty poisonous. And what he did was he fed rats normal potatoes, genetically modified potatoes, and potatoes with added lectin mixed in. And he said that something to do with the genetic modification itself caused changes to the guts of the rats. Now we now know that the line of potatoes he used had something odd about it. They didn't quite have the right amounts of protein and things. I mean, rats aren't very happy just eating potatoes anyway. So there were differences in his rats, but they weren't due to the genetic modification, which is what he said it was due to, because he went on television and said it before the paper had been published, before it had been peer-reviewed. The paper was published in the Lancet, but again it was later people redid it and said that, so there was a Royal Society commission on it that said that the conclusions, that the experimental design and statistical analysis was flawed. And that, he shouldn't have put a press release out. So it was very poorly managed as a whole. With he was treated quite badly because he said what he thought was true. But again, it eroded public confidence in genetically modified food. But the third thing that happened at the same time, so by 1999, Prince Charles weighed into the argument and said, my fears over the safety of GM food. So he said mixing genetic material from species that cannot breed naturally takes us into the area that should be left to God. We should not be meddling with the building blocks of life in this way. That's his belief. But he wrote articles for the Mail and the Telegraph, and they went on the front page, and he's done similar things since and said similar things. So guaranteed to cause the biggest disaster environmentally of all time. So by 1999, there were lots of things stacking up against GM food. So although they were being eaten, they were being sold in the UK. The tomato puree from the slow ripening tomatoes was being sold in Safeways and in Sainsbury's, and was outselling traditional ones, even though it was clearly labelled with genetically modified food. The supermarkets decided, under public pressure, to take all GM food out of their own brand and to stop stocking as much GM as possible. Now, there are GM foods on sale in the UK now, but much less than there would be in the States. So there are several foods that are approved for use in the UK. There's the GM tomatoes, but they were taken off the market. I will be talking about those in a later lecture. The soy and the maize, which are the big US or American crops, and they make their way into many of our processed foods. So unless things are labelled specifically as GM food, free, they may well have these in. Also, some of the oils come from the GM canola, and they don't have to be labelled because they're oil and they're not the gene or the product of the gene. So there are many processed foods in the UK that contain soy or maize or canola. Will include some material from GM crops. I've put a picture of cheese there because cheese is made from, virtually all the cheese on our shelf is now made from a genetically modified rennet, rather than using the one extracted from animals' stomachs to curdle the cheese, and that's entirely accepted because that's done, produced by microbes rather than by whole organisms, and people don't seem to mind that for some reason. But it's still genetically modified. I mean, it's entirely taking a gene from one organism to another. The enzyme is produced in a GM way. So what is actually grown in the UK? Now that's even less. There are no GM crops currently grown in the UK, except a very few trials now and again that you probably hear about. However, a lot of animals are fed GM feed that's imported, so a lot of soy and maize, at least 20% of animal feed comes from GM sources, from imports. Unless it's specifically labelled as GM, fed on GM-free feed, then it probably does have some GM feed in it. So it's in our food chain most definitely. But things have to be labelled in the UK. And there are nothing being commercially grown. So even though a lot of the scare stories in opposition was 10, 20 years ago, we are still pretty GM adverse in the UK, and we've managed to export that to the whole of Europe and probably around most of the world. So yeah, why? Why do we have this gut reaction against GM food? And I think one of the things is the way we grow our food. That if you've been out to the Peak District, you'll know that a lot of our national parks are living, working farms, that we see our farms as our countryside, our playground, that we have quite a strong connection to the land, and the thought of contaminating that really does worry us. Whereas in the States, where most of the world's GM food is grown, they have more of a disconnect between the cities and the land. So their national parks do not have fields in them. They have huge areas that where they can grow crops, and they can have wilderness areas that are entirely different. So their idea of a national park and a playground is different. We've been heavily populated for much longer, and we have very few wilderness areas, virtually none. A few bits in the Cairngorms. But they still have pristine areas, and they're not growing crops in them. They're growing crops in whole states where they can have no fields and have huge yields, but that's disconnected from their wildlife. So, different relationship with the land as well as the fact that many of the companies are based in the US that are producing these seed. So the US has separate wilderness and farming areas. So will Britain hold out against GM? So for the last few minutes I want to address that big question. So it costs us. Non-GM soya and maize are at least 10% more expensive, and so this is costing UK shops, so all those supermarkets that said their own brand food would not contain GM and still does not, it's costing them millions a year. Terry Leahy, who when he retired from running Tesco's a few years ago, said he thought that perhaps they had made a mistake and they should reconsider. Our environment minister a few years ago was calling on Europe to find a way forward for GM, so there are these sort of rumbling noises that maybe we should think again. So over 50% of farmers surveyed said they would consider growing GM crops if it was licensed by the government. So, you know, some farmers would like to have the choice, to try, because they're competing against farms in the world that are allowed to grow GM crops at a lower price. So, I mean, there's several things going on, but at the same time, the Scottish government has said that Scotland is GM free, and that's hard. And other areas of the UK have said there are. So there's all sorts of dichotomy of who wants to do what. So will we hold out? I don't know. Things are changing. What about Brexit? We're not going to come under the EU's rules anymore, most probably. So the Common Agricultural Policy is costing Europeans about €100 per head. So even Europe knows it's expensive. But because the big companies that are producing GM food and have bought up many of the smaller companies that have developed GM crops. So they're mostly coming from Monsanto, Syngenta, DuPont. These are US and Swiss-based companies. They're not European companies. Most of the companies that are prepared to develop GM crops have left Europe. We used to be really good at it, and then the companies left because we wouldn't sell it. And they've moved mostly to the US. But the EU does not want to be dependent on the outside for its seed, so it's quite hard for the EU to start growing these crops because they've got to buy them in from outside, and then we become dependent on someone else for our seed. So there are political reasons why we would also have difficulty accepting it whilst part of the EU. And indeed, in 2018, when gene editing, which perhaps offered a way forward, was considered, the EU again blocked the use of gene editing in food. And I mean, this is a difficult one because I don't really know how they're going to police it, because I don't know how they can tell that something has been produced through gene editing rather than another form of mutagenesis if the Cas9 has been bred out. So I think that's going to be really hard for them to police. So in the UK, the younger generation are more supportive of GM crops. So this was a Populous survey in 2018, with 67% of adults aged 18 to 30 agreeing that GM crops can play a major role in making UK farming more sustainable for the future, with 20% objecting to the use of GM editing in agriculture. So it appears that the younger generation are more open to looking again at GM crops in the UK, but whether it will change in the next few years, I don't know, because there is still huge opposition against it. I think it's still hard. So, did I have anything else to say? So I think that's where I want to finish today, and tomorrow Stuart is going to tell you a bit more about different breeding techniques. He'll tell you more about the Green Revolution, and then he's going to move on to other technologies about how you could engineer GM crops. I have put a reading list on the website of things I use to make my lectures if you want to look anything up, and links to web pages on the Blackboard site, and I think mine and Stuart's next few lectures are already up there. You've just done some grinding up and down. It's okay. I don't know. Early next week, I think. Whenever Barbara has time, Stuart will probably email you. I know he was asking her this morning.
Okay, thank you.
That's right.
Yeah, like about my project, if you decide anything about it.
This is choice that only people reach.
Well, first we need to train on way to think about what you can do. So we need to know what you're able to do in life before what you can decide what you will be doing.
Because it's actually worse for the environment, not better.
Well, we did talk to you about a number of different options.
Yeah, and make that decision. Exactly. Every product is different.
What we need to read a bit more is about what's happening at huge monopoly and how that's more like that's kind of things
They've
like they
sued farmers because a neighbouring farm has planted their seeds, and when they're sowing them, the wind has blown the seeds to another farm that hasn't paid them, and they've sued them for patent infringement.
that's my problem with
Yeah.
them. They're also patenting plants
That's
and
the actual
like I've actually agreed that it's
with the GM company.
exactly.
Yeah.
Which is kind of effective capitalist system.
Yeah,
Yeah.
or you need to have very strong rules as to how companies are allowed to interact with people who grow their food,
Yeah.
so you don't exploit small, especially small farmers.
But
Yeah.
another thing also we've done with engineers, you have to buy seeds from them.
Every year, yeah.
They've engineered some of their plants to require their pesticides.
Oh.
Yeah, and that's another capitalist issue, because
Yeah.
like if you're trying to make money, that's exactly what I would do. Quite frankly, that's a perfectly logical
Yeah,
choice.
exactly.
It's just shit.
That's why I feel like the outrage on GMs is like focused in the wrong
Yeah.
direction.
Yeah.
Like it's safe, you can eat food, you can have like healthier and more food, but then just if you're
Yeah,
the outrage, just
People
get
get exploited.
get down the